Black holes might be the key to crossing the galaxy. Not by falling into one, that would kill you, but by using one like a slingshot. It sounds like science fiction, but it's real physics. And some scientists think it's one of the few ways humanity could actually reach other star systems without waiting millions of years. Here's the problem with space travel: distance. The nearest star to us, Proxima Centauri, is about 4.2 light-years away. That's roughly 40 trillion kilometers. Our fastest spacecraft, Voyager 1, is moving at about 61,000 kilometers per hour. At that speed, it would take over 73,000 years to get there. Agriculture has only existed for about 12,000 years. Writing has been around for maybe 5,000. If ancient Egyptians had launched Voyager 1 toward Proxima Centauri, it still wouldn't be there yet. So we need to go faster, a lot faster. And that's where black holes come in. The trick is called a gravitational slingshot. We already use this with planets. When a spacecraft flies past a planet, it can steal a bit of the planet's momentum and speed up. Voyager 2 did this with Jupiter, Saturn, Uranus, and Neptune. Each flyby gave it a boost. But planets are weak. They can only give you a small push. But black holes? Yeah, they're different. A black hole has so much gravity that it warps space-time itself. If you fly past one at the right angle and the right speed, you can pick up an insane amount of velocity. We're talking a significant fraction of the speed of light. Let me put that in perspective. Light moves at about 300,000 kilometers per second. If you could reach even 10% of that speed, you'd get to Proxima Centauri in about 42 years. Still a long time, but doable within a human lifetime. At 50% of light speed, you'd make it in under 9 years. Black holes could, in theory, get you there. You approach a black hole on a carefully calculated path. As you get closer, the black hole's gravity pulls you in and accelerates you to extreme speeds. Then, if you've timed it right, you whip around the black hole and shoot out the other side, moving way faster than you came in. The closer you get to the black hole, the faster you go. But there's a limit. Get too close and you cross the event horizon, the point of no return. Once you're past that, you're not coming back out. You're stuck, falling toward the singularity at the center, where you'd be crushed into nothing. Mathematically, it works. In 2020, researchers ran simulations showing that a spacecraft could approach a black hole, use its gravity to accelerate, and come out the other side, moving it up to 10% the speed of light. But here's the catch. You need to find the right black hole. Not all black holes are the same. Some are massive and slow. Others are smaller and spinning incredibly fast. The fast spinning ones are better for this because they drag space-time around with them, creating a kind of current you can ride. These are called Kerr black holes, and they're the ones you'd want. A spinning black hole could potentially boost you to speeds a stationary one couldn't. The problem? The nearest black hole we know of is about 1,600 light-years away. That's way too far. Let's say there's a black hole a few light-years away, and we send a ship toward it. What would that journey look like? First, you'd need a ship that could survive the trip. Black holes don't just have gravity, they emit radiation. As matter falls into a black hole, it heats up and releases intense X-rays and gamma rays. You'd need serious shielding to avoid getting cooked. Then there's the gravity itself. As you approach, the gravitational forces would start to vary wildly depending on where you are. Your ship would experience tidal forces, stretching on one side and compressing on the other. Get too close, and those forces would rip you apart. That's the spaghettification you've probably heard about. There's another idea, even wilder. Some physicists think you could use a binary black hole system, two black holes orbiting each other. If you flew through the space between them at the right moment, you could get boosted by both. It's called a chaotic slingshot, and the math suggests it could accelerate you to even higher speeds. The downside? It's way more unpredictable. Two black holes orbiting each other create a constantly shifting gravitational landscape. Navigating that would be like threading a needle while riding a motorcycle through an earthquake. But in theory, it's possible. Now, here's the part that gets really interesting. A black hole slingshot doesn't just speed you up, it also messes with time. Einstein's relativity tells us that time moves slower in strong gravitational fields. So as you approach the black hole, time for you would slow down compared to the rest of the universe. You might experience the flyby as lasting a few hours, but for someone back on Earth, days or even weeks could pass. It's not time travel exactly, but it's close. Of course, this all assumes we can build a ship that survives the trip, find a black hole close enough to use, and solve about 1,000 other engineering problems. We're nowhere near that right now. It won't happen soon, maybe not in our lifetimes, but someday, if humanity wants to cross the galaxy, we might not need to invent travel that is faster than the speed of light. We might just need to find the right black hole and hold on tight. If you enjoyed this video, consider liking and subscribing to not miss a future upload.